In this video, we will see what is a deadlock, difference between deadlock and starvation, necessary conditions for deadlock and strategies for handling a deadlock. In operating systems, processes uses resources in the following way. 1. It requests as a resource and uses the resource and releases the resources. Here resources means it may be a disk, CPU, input output devices, memory, anything. Deadlock is a situation where a set of processes are blocked because each process is holding a resource and waiting for another resource acquired by some other processes. Consider an example when two trains are coming toward each other on the same track and there is only one track. None of the trains can move once they are in front of each other. A similar situation occurs in operating system when there are two or more processes that hold some resources and wait for resources held by other processes. Here we can demonstrate deadlock here. Here resource 1, which is maybe a disk, held by process 1, and process 1 waiting for resource 2, it may be an input output device. Now this resource 2 is allocated to process 2, and now process 2 is waiting for resource 1, which is held by process 1. Now this will create a circle and each process is waiting for another process to release its resources. So none of the process will execute. Now this is a deadlock situation. And what is the difference between a starvation and a deadlock? Deadlock is a situation where process got blocked and no processes proceeds. And in starvation is a situation where the low priority process got blocked and the higher priority processes proceed. Deadlock is an infinite waiting, whereas starvation is a long waiting but not infinite. Every deadlock is always a starvation, but every starvation need not be a deadlock. The requested resources is blocked by other processes in deadlock, and the request resources is continuously be used by the higher priority processes in starvation. Deadlock happens when mutual exclusion, hold and wait, no preemption, and circular wait occurs simultaneously. These are the four necessary conditions for a deadlock. It occurs due to the uncontrolled priority and resource management for starvation. These are the four necessary conditions for a deadlock. There are four conditions. These are like legs for a table, four legs for a table. Mutual exclusion. A resource can only be shared in a mutually exclusive manner. Here mutually exclusive means only one process can use the resource at a time. It implies if two processes cannot use the same resource at the same time. Hold and wait. Second condition, hold and wait. A process wait for some resources while holding another resources at the same time. Third condition, no preemption. The process which once scheduled will be executed till the completion. No other processes can be scheduled by the scheduler meanwhile. Circular wait. Fourth condition, all the processes must be waiting for the resources in a cyclic manner so that the last process is waiting for the resource which is held by the first process. This is a circular wait. So these are the four necessary conditions. All these conditions must occur in order to go for a deadlock. Now we have strategies, four strategies for handling a deadlock. First strategy, deadlock ignorance. This is the most widely used approach among all the mechanisms. This is being used by many operating systems, mainly for end users. In this approach, the operating system assumes that deadlock never occurs. It simply ignores deadlock. This approach is best suitable for a single end user system where user uses the system only for browsing and all other normal stuff. In these type of systems, the user has to simply restart the computer in the case of deadlock. Windows and Linux are mainly using this approach. Second strategy here, deadlock prevention. We early talk about 4 necessary conditions. Deadlock happens only when mutual exclusion, hold and wait, no preemption, and circular wait holds simultaneously. If it is possible to violate one of the 4 conditions at any time, then the deadlock can never occur in the system. The idea behind the approach is very simple, that we have to fail one of the 4 conditions, but there can be a big argument on its physical implementation in the system. Next strategy, deadlock avoidance. In deadlock avoidance, the operating system checks whether the system is in safe state or in unsafe state at every step which the operating system performs. The process continues until the system is in safe state. Once the system moves to unsafe state, the operating system has to backtrack the one step. In simple words, the operating system reviews each allocation so that the allocation does not cause the deadlock in the system. We use Banker's algorithm to implement deadlock avoidance. We will see Banker's algorithm in detail in next coming video. And the last strategy, deadlock detection and recovery. This approach let the processes fall in deadlock and then periodically check whether deadlock occur in the system or not. If it occurs, then it applies some of the recovery methods to the system to get rid of deadlock. Okay. In next coming videos, we will see deadlock avoidance and deadlock prevention strategies in detail.